Crash Course. Today we continue our discussion about Python, and we are going to see these topics in here. First, we are going to solve the previous session example and see how should we write the code that detects the prime numbers in a list. Then you're going to learn how to install different packages with pip. Then we will learn how to use Numpy, which is very popular package for working with matrices and manipulation of matrices. Then for plotting, we are going to learn about Matplotlib, and then we are going to learn about how to read file, how to write files, and actually in very simple form, because reading and writing files has many different ways, but we are going to learn the simplest way to do that. And at last, we are going to see an example about a regression to use all of these steps. Okay, so now we want to write a function which detects the prime numbers in a list. So first, before you start to code the program, you should think about that. You could do that on paper or anything else. You don't need to just go to your computer and start coding. Before that, just take some time and think about the problem, about the algorithm that you want to use to solve the problem. So in this problem, we want to detect prime numbers in a list. Okay, how could we do that? Okay, let's forget about Python. How you do that in the real world. Okay, for solving this problem, you probably trying to make a loop in your mind that first check this element, then check this element that is prime or not, then this element, and so on. So probably you create another list in your mind, then you have a function that takes a number, okay, and then ask yourself, okay, is this prime or not? Then that function returns you true or false. If the return value is true, then you put this element in here. If it is false, you just throw it away. So in this case, for 4, it is not prime because we actually explain it in a short, but just for now, just suppose that we know that it is not prime, so we don't put it there. For 5, it is prime, so we put it here. For 6, it is not, and for 12, it is not, and for 19, it is a prime number. So our return list will be 5 and 19. Okay, now the question is, okay, how should we write the function that check a number is prime or not? So just note that how we are breaking down the problem into smaller problems, okay, then solve smaller chunk of problem. So now we want to create an algorithm for detecting a number is prime or not. Okay, How should we do that? Okay, the way is so simple. For knowing the a number is prime or not, you just you should have a condition that that number, let's say it is, for now it is 5. Okay, that number just could be divided by the number itself and 1. Okay, and also it should not be 1 itself, because 1 is not prime. Okay, so if I have 4, it could be divided by 1, 2, and 4. So it is not prime. Okay, because we have 2 in here. But if we have 19, we have 1 and 19. Okay, so it is prime. So we just need a loop. Let's say our number now is n. We just need a loop for I, let's say from 1 to n. We check if the remainder of that number to I is 0, means that that number is not prime. Okay, so we could return false. Okay, else we go to the next loop. Okay, then after all of this operation, if there was no any returning value, then we return true, which means that okay, our number is prime. But take a look at this. Does that work or not? Always check your algorithm. Okay, sometimes maybe it seems your algorithm is really good and works, but when you check that for a simple example, it fails. Let's check it. Okay, let's say we have 4. Okay, then we go through this algorithm. Okay, for I from 1 to n. So from I is 1 to 4. So at first iteration, the I is 1. Okay, if 4, this means the remainder value. So when you have a division, let's say you have 6 over 3, the answer, this is the remainder value. Okay, so if the remainder value of 4 divided by 1 is equal to 0, which is 0 actually, because 4 divided by 1 is 4, so the remainder is 0. Okay, then we return false. Okay, so in that case we return false, means that okay, we tell that 4 is not prime. Okay, great. It seems that our algorithm works perfect, but let's say we have a prime number 5, which we know that it is prime. So again, if 5, if the remainder of 5 to 1 is equal to 0, which is 0, then we return false, which states that the 5 is not prime. So this is wrong actually. So this is important, that now you should know how to fix that. For fixing that, we just need to create our loop from 2 okay, because for every number greater than 1, the reminder for 1 is equal to 0. So if you change that to 2, it is okay. Okay, now this works perfect. Okay, now we could go and write our program, because now we know how should we solve the problem. So we have a function that returns the prime list, the prime numbers in a list. Okay, so get prime elements, and it gets a list. Let's call that my list. Then we have another function that check a number is prime or not. Okay, check number is prime or not. Okay, and it takes a number. Okay, and here we have our main method, which we want to test our functions. Okay, in here we should first create an empty list, then we just need a loop which iterates over the elements of my list. So for element in my list, we should just check a number is prime or not, that element is prime or not. So check number is prime or not of element. So we want to know that element is prime or not. Then if that number was prime, we extend the result, okay, with that element. Else we do nothing. So we don't need to write anything in here. Okay, so now we should complete this section. Okay, if number is equal to 1, okay, return false, because we know that 1 is not prime. Else we use a loop for I in range 2 to that number. If the remainder of number to I is equal to 0, return false. It means that that number is not prime. Otherwise return true. So it means that in this case that number is prime, and just we consider that the numbers are positive. Okay, so we don't have negative numbers, so we don't have to worry about them. Now let's check our functions. Let's say we have 3, 5, and in here we should have a return result, right? Or maybe it is better to name it prime elements. It is more meaningful. 3, 5, 6, 9, 11, 13. Okay, then print get prime elements of A. If we run that, as you could see in here, we have 3, 5, 11, and 13, which are the prime elements of list A. Okay, so now you could write this program for yourself to actually get hands-on on writing Python program. Okay, so that's it. Yeah, that is so simple. Just note that you do not need to code your program at first. At first, you should think about your problem on paper or board or anything else, or just in your mind, or how should I solve this problem, okay? Forget about the syntax, the Python or the language. Just think for yourself that how you solve this problem, okay? Then divide your problem into smaller problems. Like this, you saw that we divided the problem into 2 different functions, okay? Then you could actually code those smaller problems. Okay. The next thing, so it is done. The next thing is install packages with pip. Okay. In here we actually ourselves write some functions, okay? You could write some function and use them in different files. I told you a very great thing about Python is that there are lots of libraries and packages for Python, and package means that a bunch of functions or classes in a file, okay? So for using those functions, we could use packages, okay? For installing packages, Python by default has pip, okay? Pip is the default package manager of Python. There are lots of packages for Python, but some of them are very important, and probably you oftenly use them in Python, so we are going to learn about them. For installing a package in Python with pip, you just need to write, if you use Python 3, you should use 3 in here, install name of your package, okay? Which could be anything, okay? Now, for example, here we want to work with Numpy and Matplotlib, so you could write Numpy in here, then it will be installed on your device, okay? And the same for Matplotlib, okay? So now you have installed Numpy and Matplotlib. Now we want to get familiar a little with Numpy and Matplotlib. Numpy actually is a package in Python, as I mentioned, to work with matrices and numbers in Python. If you work with MATLAB, it is very the functions in MATLAB are very similar to the functions and methods that Numpy has, and you could use the similar things in Python with Numpy package, okay? And it has very good documentation. You could search for that. Let's say you want to first convert this list to NumPy array, then okay, for using the package NumPy, you should write import NumPy. Then you could use the methods with writing numpy.array something, okay? But because writing numpy or just large packages name are sometimes boring or difficult for you, you could just use you could assign another short name for that. Let's say it is as np. So instead of using numpy, I could use np. Okay, so np that array a. So now if I print a, I will have the numpy array of my list. If I want to be sure, I could write its type. Now I will have the numpy array. Okay, so why should I define numpy array? Okay, as I mentioned, numpy has lots of methods for working with matrices and this kind of things. For example, let's say we want to create matrix. If we print, we have the identity matrix, then we could use, for example, np dot pseudo inverse for getting the pseudo inverse of our matrix. Okay, then print b, and we know that the inverse matrix of identity is identity, so maybe it is pointless in here, but now we see that we could do lots of things with numpy matrix. And actually you don't need to memorize all of these methods. Let's say you want to find the eigenvalues of a matrix with numpy. So you could search that eigenvalues numpy array. Okay, as you could see in here, you will go to numpy documentation, then you will have an example, a very simple example from that. And as you could see, with just you could get eigenvalues and eigenvectors of a matrix. Okay, it is great. So with numpy, if I want to be honest, you probably store all of your data in numpy form. So it is very important to know how to use numpy and how to work with that. Okay. Okay. Now the next thing is Matplotlib. Matplotlib package is for plotting different things. Okay, it is like the plot of Matlab. If you want to plot something, you could use Matplotlib. Let's say we have x, which is actually one of the things that I told you, NumPy is very similar to MATLAB. We could use linspace in NumPy, which is very similar to linspace in MATLAB, which creates for you some different numbers from 0 to 5, and the number of them is 1000. So if you print x, then you will have from 0, as you could see here, from 0 to 5. Okay, now I get sign of them, then I could print that. Now I just want to let's say it is np p. As you could see, I could do anything probably with Numpy very easily. Okay, now I want to plot that. For this, I could import matplotlib.pyplot as plt for using shorter name instead of this. Then I use plot method or function for plotting data. Okay, if you run that, you will see nothing. For showing the plot, you should use plt.show. Now we will have very nice plot. If you want to have some title, you will have add that. If you want label, you could have that, and or if you want to define a range for your axis, which is x and y, you could set that. Okay, that is so easy to do and work with Matplotlib. If you want to let's bring down the number of data points to 10. Then, as you could see here, Matplotlib connects the discrete data points together. If you want to plot them separately, we could use O in here. Now we will have discrete data points. If you want to have specific color, we could actually use another argument for color, or just in here give a short name for color. Actually, using color in Matplotlib, you have so many ways to do that. You could read how to color in Matplotlib, and a section in Matplotlib documentation is for using colors. But a very simple thing is to just, let's say I want green. Now I add G in here. Now I have green dots for my data, and I have title for my plot, and y-axis name and x-axis name. Okay, so this is so great about Matplotlib. Now you know how to plot basic things in Python. Okay, now we want to know how to read and write file in Python. Okay, let's say you have something like let's say you have a file. Let's create the file in here, which is let's call it my text or CSV or anything. Okay, now I have it in here. Now I want to edit that. Okay, just put some value in there, some names. Then, okay, John, and let's say just some random things. Okay, that's it, and some enters. Okay, now in here we want to read that file. How should we do that? For reading CSV file, you could actually download a package to do that. Okay, for reading CSV file, we have a package in Python which you could actually install that with pip in here. But now we don't need to do that, and we could read files in Python without installing anything. For doing that, first you should create a handle for your file. Let's do this with open. So let's open, then you need your file name. Because my file is in this directory, I just use its relative path in here, and I want to just read my file. Okay, now the second argument is actually the mode that I want to work. Okay, then I could put R, W, or A. When I put R means that I want just to read the file. Okay, when I put W means that I want to create a new file and write in that. When I put A means that I want to append to some lines to the existing file. Okay, now I want to read that file, so I just use R in here. Now if I want to now read the lines, I could easily use read lines method of that handle. Now if I print lines, I could see in here these are the different lines. This is one line, this is one line, and so on. And now you could see that I have some enter. Okay, now you should remember how to remove those enters, because they are not very informative for us. So because this is a list, I could use filter, right? So I filter my list if that element is equal to enter, then if it is not equal to enter, then we want to keep that. Okay, and we want to do that on lines. Now if we print lines, we will have this. Okay, and also we want to remove these. Okay, for removing these enters, we could use map as follows. We want to use strip. We know that a strip removes enters at the end of elements and at the end of a string. So, and we want to run that okay, now that's it. Now I have my data. So you should know how to clean your data to use that. Now you kind of know how to use that. Now let's say you want to print those names to the user. Okay, for line in lines print line. Okay, now I have in each line I have two names, and if you want to separate those names, you could use split with comma delimiter. Now as you could see in here, we could split them. Okay, we talked about split. Now I think this is a good recap for you to remember how to use filter, map, or string methods to clean our files while we want to read a file. Okay, so this is how you could actually read a file. Now let's say you want to write a file, and write a file also is very easy. For writing a file or appending file, you could use W, or for append you could use A. Okay, let's use A. F.write line, and then you should pass an list to that. Let's say it is my name and your name. Okay, if I run that, then I open that with text editor, then I will have my name and your name after my file, as you could see in here. So that's it. Now I have write my elements. Okay, so now you know, but actually you should know that, as I mentioned, there are lots of other packages which you could make your work easier for writing and reading files, especially when you work with dataset. I highly recommend to install pandas and learn how to read and write files, and also work with datasets with pandas. Maybe we cover that in next sessions, but actually using that is not hard. It is actually pretty straightforward to use that, and most of data scientists use pandas for reading datasets, so you could take a look at that. Okay, now as the last example, we want to create a fake dataset and then visualize those data and create a regression model for that. Okay. Okay, now you should know how to do that. First, so we want to create data. Okay, then we want to save our data in a file. Then we want to load our data. Then we want to visualize our data. Then we want to fit model to our data. Then we want to visualize model prediction, right? Okay, how should we do this? How should we do this? We do this step by step. Okay. First, let's say our data is something like okay, first we import Numpy as NP, then we create uniform random Numpy from 0 to let's say to 20, then the size is 200 data points. Now if we print X, you could see that we have 200 data points from 0 to 20. Now let's say our model is, our data is something like 2 times x, so it is really nice model, nice data, plus a random noise. So I want, we have 0 mean and standard deviation of 0.1. Now for visualizing data, I import Matplotlib, then now I could plot x and y, they are discrete. Okay, as you could see in here, I have my data, but they are really good. Let's say this is 3 now, but and the size is 200. For now, you see that if you repeat a variable more than once or even once, but this is not very meaningful if you want to read that file again. So it is better to define n of samples, which now you know what it is stand for. Now you could use this variable in here, and let's say this is 10. Oh, this is maybe too much. Okay, this is good. Now this is our data, okay, and let's say okay, good. Now we want to save those data in a CSV file. So we want to create a function, save data in CSV. It takes file path or file name. Now first you should create a handle for that. So create file name and as W, then f.readlines. We should convert these to lists for writing them in file, right? So we could use x. If you want to read write them line by line, we could use for. Or let me show you very little trick for creating for loop when you have two lists and you want to have a for loop on both of them element by element. You could use zip, which just for showing you how it works, if I write print the elements in here, I call the function with, let's say this is data, that's CSV and x and y. You could see that the values are printed, the x and y with in each iteration with corresponding values of each other. Okay, So you could use zip file to actually maybe it is better to see what zip do in here. As you could see in here, the zip actually zip the values of x and y together. So this is the first element of x, this is the first element of y, and so on. Okay, so I could use for loop for both x and y. Then I want to have f dot write lines element x and element y, right? So, and then return. If I run that, it tells me you passed numpy, not string, to for writing the list. Okay, for this, if you print element x, you will see that it is a float number. So you could easily convert that to a string by putting str in here. Now, if we open data, we will have them sequentially. Maybe it is better to put an enter after each of them. So maybe it is better to write those like this. Okay, now you will see that we have the data line by line, right? Okay. Now, okay. Now we have our data. We want to read our data. So we want to define load data, which get file name and returns the x and y values. For this, we open file name as in read mode, then lines are equal to f.readLine. So if we print lines in here, we just should call you could see that we have something like this. Okay, but we have not saved our data properly because we haven't any kind of space in here. So we use Control Z to back. Then we should use some kind of separator in there. Okay, now it is okay. Okay, def of load data file name, and okay, open file name, and in read mode for then we read lines. If we print lines now, we will have as you could see, now we could separate those. First, we could create empty list of x and y. Then for line in lines. Actually, you could do these in more Pythonic way and more efficient way, but just now for sake of simplicity and just showing the example, we don't want to make it complicated, so we may keep it very simple. So for line inlines, we want to extend our x is line dot split. So let's first extract the elements. First element is line, and second element is line dot split, right? If we print first element and second element, you see that we will have these, but we also have inter. As you could see in here, inter does not show in here, and it is shown with inter itself. Okay, so we should remove the enter from the second element. Okay, so we could use second element that, or at first we could use a strip for our line, strip, then split that. Okay, now if we print that, now inter is gone. Okay, now we should convert those to float. Okay, that's it. Now we could use y.extend this. Okay, then we return x and y. So in here I have the value of x and y in here. Print x. We could again visualize them to make sure that they are so. As you could see that they are okay. So until now we saved our data and load our data, but now we want to fit a regression model on that. For doing that, we could actually done that with scalar. Okay, scalar regression model. In here you could see that actually we saw an example for making linear regression. So first you should import linear regression from scalar linear model, but before that you should install scalar from here. Okay, after installing that, you could import that in here. Then you just need to follow this example. It is that simple. So you just create a linear regression instance, then fit that on the data. Okay, now if we print reg, we will see that okay, this is good to see. Now we will see that it throws us an error about the shape of our data. Okay, always for making sure everything is okay, you could convert your data to Numpy. then reshape your data to have -1 and 1. It means that when you write -1 and 1, it means that it has one column, and -1 means that do it with suitable value. Okay, so in this case, when I put 1 in here, this will be the number of samples. Okay, if I put here 2, this would be half number of samples, because the multiplication of these two should be the same. Okay, so -1 and 1, and we do the same thing for y. Now, okay, we will see that our regression model is fine now. Okay, and we could actually get some prediction from our model now. For getting new prediction, let's create some new values. Here from -5 to, let's say, 30, and the size is 50 points. Then we actually should reshape that, or maybe it is okay itself. Just we could check that y prediction. So we should reshape that. Okay. Okay. For we plot the original data with red and plot the prediction with green. So as you could see in here, we have, this is the linear regression model output. Okay, we could actually plot that with line. So now, as you could see, we saw a little example to how to save data, how to load data, and how to feed a linear regression model or any other model to our data. So this is, I think, so good to know how to write a mini example for yourself. You could practice this with yourself, and it is very good to know how to use those. Okay, now I think actually there are lots of other details about Python. We actually didn't talk about classes or object-oriented programming, or lots of other useful packages, but or iterators. We actually see some of them in the next sessions. Maybe in the deep learning part, we see some of the maybe iterators, because if I introduce you all of them in here, maybe it is so boring and pointless, but you will get the necessity of defining and using iterators when we are in the deep learning part. So I prefer to use them and learn and teach them there. Okay, but for now, I think you are ready to actually get familiar with packages like pandas or Seaborn, or using Matplotlib and Numpy in more efficient way. And so I hope you enjoy from this session and be able to now write your ideas in Python and code your ideas in Python. Hope to see you in the next session. Bye.